Hi guys, here we're going to look at the 4 basic rules for fractions. So let's start off with adding and subtracting. Now, these are all the same method. This is where we make the bottoms the same. If you ever get stuck, just think, right, what is a third plus another third? Now, if you were to draw this as a picture, for example, like this, you realize you can do this very easily. So 1/3 plus another third is quite simply 2/3. So you can only add fractions when we have these bottom numbers, the denominators the same. Now, to do this quickly and easily, you've got to think of the 5 times table and your 4 times table and think of a number they're both in. So the lowest common multiple of these two numbers, which in this case happens to be them multiplied together, which is 20. So now you've got to think, how can I write this as an equivalent fraction with 20 on the bottom? And because you times this one by 4, you have to do the same to the whole fraction, which is therefore 12 over 20. This is simply, well, this one is simply that times 4. Now if we do the same process, it's not times by 4, which is a common error that people do. It's actually 5 times bigger, because 4 times 5 is 20, so then a quarter as an equivalent fraction is 5 over 20. Now that you have the denominators the same, we can now add them. So 12 over 20 plus 5 over 20 is simply 17 over 20. Exactly the same as subtraction. I've chosen this one because it's not simply these times together. You can do that and get 108, but you'll be saving yourself a lot of time and effort if you go for the lowest common multiple. In this case, 36 is in both of these times tables. 9 times 4 is 36, so we times this whole fraction by 4. And 12 times 3 is 36, so we times this whole fraction by 3. So 16 over 36, take away 3 over 36, leaves us with 13 over 36. Now if the question is top heavy, just take it into, if it's mixed, you make it top heavy first. So there's 2 whole ones and 2 fifths. Well, because we're thinking about fifths, how many fifths are in a whole 2? Well, that'd be 10. 10 over 5 is 2, plus an extra 2, that'd be 14. And this one we're talking about quarters, so how many quarters are there in a whole one? Well, that's 4, plus this extra 3 is 7 quarters. Now we have to do exactly the same, just squish this in here, making the bottoms the same. So we're timesing this one by 4. So if you don't like timesing a biggish number like that by 4, it's just doubling and doubling again. So it's 56. And this one we're timesing by 5, which is 35. Bottoms are the same, so we can now add them. What's that? 80, 91 over 20. Now you can put this back into like a mixed fraction form. So how many 20s are there in 91? Well, that would be 4. 4 lots of 20 is 80. And then we have the 11 left over. So those are the same thing. Subtraction, I'll just show you again. Thirds this time. So how many thirds are there in a whole 2? Well, that's 6 thirds plus an extra. That's 7. How many quarters are there in a whole 1? Well, that's 4 quarters plus an extra 1. That is 5 quarters. 12 is the lowest common multiple of both 3 and 4. Times this one by 4, so it's 28. Times this one by 3, which is 15. And if I subtract those, I get 13 over 12, which once again I can see is over a whole 1. And we have the remainder. So I've gone through that pretty fast, but like I said in the previous one, this is just a recap just to get you ready for the test 7 days in advance. Now, dividing fractions. When you divide any numbers, you normally use your times table to answer the question. For example, if I wrote this, what is 20 divided by 4? You might automatically say 5, but most people say, well, how many 4s go into 20? 4 times what is 20? So you automatically have always turned divide into a times. So that's exactly what we do. We change it into a times, but we can't do that unless we reciprocate it. And what I mean by that is you flip the second one over. So you change it into a times and you reciprocate the second one. And then once you've done that, it's just times the tops and times the bottoms, which again I can make into a mixed fraction. There's only 1 9 and 15, and 6 over 9, or 1 2/3 would be a better answer for that. This confuses a lot of people because there's no fraction, and where there's a fraction you need another fraction. So we can do that. We can make this into a fraction by simply doing that. I'm dividing by 3, and this still is 3. So I rewrite it, change to a times, reciprocate the second fraction, times the tops, and times the bottoms. And we're done. Same thing here. We have to turn it into a fraction to make it easy for ourselves. What a lot of people do, they do that times 5 and that times 5. That's not what the question is saying. It's this fraction times 5. And that is not the same as doubling top and bottom by 5. So if I do this, it now proves that is the case. So that's 30 and 7. Times the tops, times the bottoms. How many 7s go into 30? 4, with 2 left over. And that is how you do all the 4 rules.